Hello, everybody. Thanks you to be at this presentation. So my name is Jean-Charles Lesage. And if you put my last name into Google Translate, you will got JC the Wise. So it seems I was born to work in the security market. Anyway, this presentation will give you a short overview of who is Idemia, and then we will move to the main subject, which is simplifying deployment, but keeping security, full security for your LoRaWAN system. Okay. So who we are? Idemia, in fact, is the combination of two main players coming from the smart card industry, Morpho and also Overture Technologies. So we are currently supplying chips, secure OS for different market, banking, institution, banking cards, ID, passport, SIM cards for telecom operator. We are a company that is 3 billion euro revenue. We are providing biometric solution, for example, for the Changi airport, where you can go to the plane without showing anything, no passport, only your biometrics things. So the ability to maintain the full security of a very sensitive credential without any exposure. That is also what we are proposing as a solution for the LoRaWAN environment. So something really important is we want to open a set of security services that needs to be transparent for device maker, network operator, service provider, device operator. We all know that this IoT ecosystem, especially around LoRaWAN, is complex, and that is what we want to bring is really transparent security solution to ease one of the main issues currently on the market, which is the deployment of devices. So just a brief overview, you have seen that on the other conference this morning. So you have a set of keys that you have to share with module makers, device makers. You have to provision the device. You have to provision the joint server. You have to provision the network server. And you have to keep this secret secret. Indeed, security is based on secret. So this secret needs to stay secret. And this is key. Oh, it's a bit turning around, but here is the ID. No key exposure and easing the key sharing from the device up to the application server, but also the joint server and the network server. So for this, we are providing what we call a trusted digital identity, which is not only the APP key for LoRaWAN. Compared to what is human identity, which is quite stable, in fact, even if there are some use cases where your identity is changing. You can change your nationality. You can be a male and become a female. It is a use case that happens sometimes, but it is, let's say, human identity is quite stable compared to what is IoT. An IoT device will belong to a subscriber. This subscriber will use maybe a module, LoRaWAN module. He will build a device. He will use a network operator. He will use a cloud service provider. He will use different type of communication technology. LoRaWAN is one of the network technology, but there are plenty of other communication technology. And he will use then device and service operator. So For an IoT device, this identity is composed of plenty of different credentials that you have to manage securely. How do you create this trusted digital identity? So first of all, there is this, what we call everywhere, this root of trust. This root of trust needs to be kept secret. Our solution is to propose our secure premises, the one we are using to download the banking credential into the banking cards or the identity credential into passport. Okay, so certify the data centers to inject this root of trust in secure element. Secure element, which can be hardware secure element, which can be dedicated hardware for LoRaWAN, which can be dedicated hardware for automotive market, which can be eSIM for cellular communication, but which can be also software secure elements part of a standard MCU microprocessor. The idea is to share this root of trust within a digital platform, what we call at Idemia the mTrust security platform, providing a set of services that will support your use cases. And we will see what kind of use cases later. So that you can have access to this convenience that we are all looking for in order to move this market a bit more sexy, attractive, by easing the deployment of device. And then, once you have eased this deployment, you can trigger a set of security services. IoT protection is something that you need at the beginning. But then you are deploying your device for 10 or 15 years. And that is where you will need security services to renew the key in the field, to manage different use cases, changing network operator not to be stuck during 10 years to the same network operator, changing the ownership of a fleet of device, for example. So convenience and security. So for which use case in LoRaWAN? In LoRaWAN, you need to simplify the journey of this connected object. So the idea is to propose these both secure elements and digital trust platform to ease the device enrollment. QR code is part of the LoRa Alliance working group in order to see what kind of information to put on the QR code in order to ease the deployment of devices. Then you have this difficult stuff, which is the device provisioning. So providing the application session key to the application server, providing the root key to the joint server, providing the network session key to the network server, but you need to link it to a device identity. It's not only providing the credentials, it's combining the identity of the device and the credentials. Okay? And next step is device activation. We will see a bit later what are the challenges for device activation. And at the end, as I said before, you deploy your device for 10 or more years. And you need to manage in the time this device identity that might change. So the use cases is you are a big OEM, you are building smart meters, you want to deploy worldwide. You don't know at the manufacturing time, in fact, what network you will use. Will it be a public network? Will it be a private network? Will you join on home network? Will you join on visited network? Which joint server will you use? Will you use it for the whole life of your product, or will you change at a time from a joint server provider to another joint server provider? So the challenges there are clearly end-to-end security, means the ability, really, to keep these credentials secrets from the device up to the application server. I do not really like end-to-end security, saying it's end device to application server. What about the user that is behind his screen? How can he trust the data that is in front of his screen? So end-to-end for me comes a bit beyond than end device to application server. But that is not the topic of the presentation today. Well, while deployment, we talk about that. Friendly user experience. Security need to be transparent for all of these stakeholders. And finally, manage the device lifecycle management. Now, a quick question. Why should I know at the time I am manufacturing my device where will be its final destination? We have seen this morning during the microchip presentation that they have done a very good job in providing a solution with initial credentials that allow to connect to TTI. That's great. That's wonderful. But when I am manufacturing my device, at the time I am doing my device, so I need to know that I will use microchip and TTN. That may be sometimes a logistic issue. So the idea is more to replicate what is done in this cellular market, which is in fact providing a secure element with an initial bootstrap that will then be used to re-provision the device with the final credential, which could be TTI, TTN at the end, which could be joint server 1, joint server 2, whatever, network server 1, network server 2. So the idea is really this root of trust on one side, which is put on the device, a generic secure element. So for the device manufacturer, no more need except buying secure element, solder it on the PCB, that's it. No key management, cost saving, no HSM on production line, to provision the device with the keys, everything is done already. And then at the first activation, to connect to the mTrust server that will remotely re-provision the device with the final credential for the final destination. How does it work? OK. We do have a booth over there in front of Microsoft, in front of TTI, where we can show this re-provisioning mechanism. Trust me, that's not so easy to do it, at least in a secure way. So we have this device with the profile 0 corresponding to a dev UI, Idemia dev UI, an application key belonging to Idemia as well, and the app EUI, which is the address of the initial join server that will be used at the first activation of the product in order to manage the join requests. Then provide the credential to the network server, application server, GS server, in order to be able to do this re-provisioning to the final destination. So the profile 0, OK, has to be provisioned within the network server and the application and join server. OK. What is happening at the device power up? Join request, go to the gateway. OK, is forwarded. OK, the device profile 0 is activated. The join operation has been performed successfully. OK. The join accept is sent to the device back. OK. So Now we have to switch from this initial profile to the new profile. We all know that we cannot trigger downlink messages. So we have first to wait for an uplink, and then we will build a message that will be encrypted with a unique key that is only belonging to Idemia, and that will be used by the end device to decrypt the message. We will use for that the F-port administration, the administration F-port defined in the LoRaWAN specification, in order to tell the device that that is an administration message, not a service message. And then the MCU has to transmit this message, administration message, to the secure element in order to perform this reprovisioning. OK, so now we provision with the profile of the final destination. I'm not sure the animation is correctly working there, but OK. All the information is now provisioned in the network server. And at the next uplink of the device, OK, the data will be ignored by the mTrust platform because we are not here to collect data. We are just here to downlink a new profile, which can be done only following an uplink message. So at the uplink, the downlink is sent to the device, and we have now the profile one that is embedded in the end device. What is happening there? We have to trigger a message in order to switch from profile 0 to profile 1, in order to get rid of any problems during transmission. So we have to keep this profile 0 active for a while. OK. I send the switch profile command. OK. Same operation is performed. OK. The switch profile happened. I'm now on the final destination. OK. Same process, join request, but this time to the final join server that will be used, that has been chosen by the device owner, device operator. The join accept is performed, sent back to the device, and the regular data collection can happen. So it opens a set of this reprovisioning mechanism, open a large management of different use cases. You have contracted with a connectivity provider. You can move from one operator to another one. You can sell your fleet of devices. You renew the credential. You can decide for security policy. You can renew credential. You can move from an application platform to another one. You renew credential each time. And it's completely transparent for you. So do not hesitate to come to our booth, have a real demonstration. That is not a fake one. There is some random operation that you will have to perform in order to give you the guarantee that's not a fake demo, and so that you can see how it works. Thanks a lot.